Hi, Al. So today we are going to start our module number 21, which is LCA. Here you can see a graphical representation of LCA. LCA actually is life cycle assessment, which is for any material. This graphical representation shows that purpose of LCA, that LCA supports sustainable decision making. It compare alternatives and identify emissions and resource hotspots. It also improves ESG performance metrics and in mainly in construction industry. Here we have proper definition, its construction example and ESG links. First of all, we have definition that life cycle analysis or assessment, also known as life cycle assessment, is a systematic method used to evaluate the environmental impacts of a product, process, or services throughout its entire life cycle, from raw material extraction to its final disposal. Or you can simply define it as a method to assess environmental impacts of a product or project across its full life cycle. Construction example is assessing impacts of a building from material extraction to demolition. Here I will also show you in next slides. I will show you the pictorial diagram by which you can easily understand that okay, what is actually the LCA from cradle to grave. What is its ESG link? As I mentioned in the first slide, that it supports it supports environmental disclosure and sustainability strategy. So life cycle assessment identify emissions and resources hotspots. It supports sustainable decision making, compare alternatives. Construction example, like for example, comparing concrete, plain concrete or simple concrete versus green concrete. Its ESG links are it improves ESG performance metrics. Here we have life cycle stages. That what are life cycle stages? First, we are uh, uh, coming with our uh, photographic representation, that you can see that we are going to evaluating environmental impact from of any material from cradle to grave. The first stage is raw material extraction. Here you can see a photograph for the raw material which first goes into industry. Then in industry, it manufacture or material, that the processing of material or manufacturing. Then after its completion of its manufacturing, it goes for distribution and transportation to for the human use, or for example, if a product like washing machine or any plastic, so it will use for its use to human beings. Then finally, after its passing its life, it goes to final disposal. Technically, we called it grave. So this is the stage of LCA, or stages of LCA. Technically, we call it cradle to grave, from first stage to last stage, or cradle to grave. For for cradle to grave, material is surpassing a lot of stages. That first of all, raw material extraction, then manufacturing, then transportation, then construction and use, and end of life or disposal. ESG links are steel production, goes to site construction, and finally demolition and recycling. Here we have a slide for system boundaries in LCA. As I told you in last slide, that first of all, material goes from cradle to grave, then cradle to gate, then gate to gate, and then finally cradle to cradle. Construction example is cradle to grave LCA of a landfill or building project. Here we have LCA methodology, ISO 14040R44. In this LCA methodology, we have four main, you can say categories. In next lecture, I will define each and every of these four, but here you can just see the names that first in LCA methodology, first is goal and scope definition. Second one is inventory analysis. Third one is impact assessment. Fourth one is interpretation. Construction example are material quantity, takeoffs used for inventory. In this photo, you can see key elements in LCA that we have target for goal and scope definition, inventory analysis, energy, water, and emissions, impact assessment like LCIA, and final interpretation. Applications of LCA are product design, improvement, environmental labeling, and sustainability decision. Here we have environmental impact assay that we have carbon emissions. What we do in LCA actually, we do carbon emissions. We measure or calculate energy use, water consumption, waste generation, and pollution. And what are its links with ESG? It is used for carbon footprint and water risk reporting. Importance of LCA in ESG and construction are it supports net zero targets, it improves green building design, it strengthens ESG reporting, it reduces long-term risks, and it used in lead infrastructure, ESG, and climate action plans. Here we have a summary of all the lecture that life cycle analysis from cradle to grave and its key elements and its final applications. So hope you understood. Thank you for watching. We will meet with the next part of this LCA. Thanks for watching.